The final section of this chapter is sensors based on luminescence quenching. Okay, we have learned the principles of luminescence, fluorescence, and phosphorescence, and um, the luminescence may be quenched by other molecules or maybe particles. Okay, and based on this luminescence quenching, yeah, we'll learn shortly, the how we derive the equation for luminescence quenching. At any rate, let's admit that luminescence in some circumstances is quenched. Okay, and using that phenomenon, people have developed sensors, okay, based on luminescence quenching. This is one of the instruments. Okay, there are not only this one, there are several different types of instrument. Okay, this one, this box now uh, generates the light inside. There is a lamp, one or two lamps inside this box, and then the light pass through. This is a fiber optic. Okay, fiber optic means that that is light guide. Okay, light you see travel in a straight path. Okay, uh, but if we use this optical guide, yeah, and then inside there is a reflection, yeah, and then light can be directed through this the fiber optic, and then it can the light at the end now shine some molecule inside this wire. Okay, and then emitted light, okay, fluorescence or phosphorescence now taken by this optical fiber. There are not only one fiber, there are let's say two fibers. Okay, and then another fiber now receive the emitted light, and then it enters here, okay, into this box, and inside the box its intensity is measured. Okay, that way, yeah, we can monitor the phenomenon in this vial. Okay, so in this case, photons are directly monitored. Okay, you send, okay, you excite this system with uh, photon, okay, light photons, and then receive the photons whose wavelength is longer than the excited wavelengths, and then you analyze, with a detector. Okay, but in many cases, photons can be converted to electricity. You know, our textbook introduces the short, um, you know, short explanation, yeah, of how light is converted into electricity. Okay, that's called a solar cell here. Solar cell is a device that uses solar energy to convert it to electricity. Okay, um, there are many different types of solar cells. The commercially available solar cell is silicon-based solar cells. Okay, so our government also invests a lot to construct the silicon-based solar cell. But unfortunately, this silicon-based solar cell, um, the efficiency is not very high. Okay, anyway, this is the only solar cell that is commercially, available. But other than that, there are uh, other types of solar cells. So for example, dye sensitized solar cell. People use sensitizing the molecule, okay, which is called dye, and they develop the solar cells. And the history is very long, several decades, maybe. It's been developed maybe 40 years ago or so. And also there are solar cells called organic solar cells. And recently, the biosolar cells have drawn much attention. Okay, Biosolar cells, they use biological materials to receive light energy and convert into the electrons. Okay, since your textbook introduces um, the uh, the solar cell, the dye sensitized solar cell, maybe it is worthwhile to explain a little bit about that. Okay, here, although uh, your textbook, okay, box 18-1, okay, it is not explicitly states that is called dye sensitized solar cell. To fully understand the principle of this solar cell, you have to know some knowledge of semiconductor, okay, and the molecular state of dye molecules. Anyway, the structure roughly is like this one. Okay, look at that. Um, Solar cell is a kind of the electrochemical cell, so it should have two electrodes. Okay, here this is what the anode, and this part is cathode. Okay, at the anode, the oxidation reaction takes place, and at the cathode, reduction takes place. Okay, here on this is the electrode. Usually, they use transparent electrode with high electrical conductivity. The one good material is tin oxide. Okay, this is transparent, but its electrical conductivity is very high. But recently, people began to use fluorine doped tin oxide. Okay, it is called FTO. Okay, uh, because the light should pass, okay, this window, and this solution on the solution side. The surface of this FTO is coated by this one nanoparticles. They are TiO2, titanium dioxide nanoparticle. Okay, this is a semiconductor, but as you know, there are two types of semiconductors. Okay, N-type and P-type. In N-type semiconductor, the major carrier is electron, and P-type, the holes are major carriers. Okay, but you don't know. Don't worry, you don't need to fully understand. But to listen to my explanation, and this TiO2 receives solar light. Okay, the semiconductor has energy gap called the band gap. Okay, so the electrons in the valence band are now excited to the conduction band upon receiving solar light. But since the TiO2 band gap is very high, so most visible light cannot be absorbed by TiO2. Only a very small portion of near UV light is utilized. So if you use TiO2 nanoparticles, only 4% of solar light is utilized. The rest 96% of solar light is not utilized. So that's a lot of waste. Okay, so people developed this concept of dye sensitized solar cell. Okay, you know this the TiO2 nanoparticle is coated with this molecule. Okay, this is TiO2 particle, and this molecule is called sensitizer. Okay, sensitizer. This sensitizer molecules harvest, that means collect solar light. Okay, and then the electrons are excited to um, LUMO from HOMO. Okay, and then the electrons generated from this sensitizer now injected into the conduction band of these TiO2 nanoparticles, and then eventually electrons are uh, going to this FTO, the anode. Okay, and then through the external electrical circuit, okay, the electrons are moving toward the cathode. Okay, on the cathode, electrons should be consumed. Okay, but inside this cell, you put this one iodide, and this is a triiodide ion. Okay, and this electrons now goes to triiodide, and this triiodide receiving electrons is reduced to iodide. Okay, so as long as you shine this anode with visible light, and, this process uh, keeps going on. Okay, and here on the external circuit you attach electrical load. Okay, it can be maybe your cell phone, your computer. If you make this the solar cell very big, and then it can be your refrigerator, your TV. Okay, yeah. So this is quite noble. Okay, you only need solar light. Yeah, and then light, visible light now converted to electricity. Okay, that's the principle of here dye sensitized solar cell. So it has been studied really extensively. So when I went to the society meeting, a domestic meeting, and overseas meeting, and then I found a lot of people are doing the TSSC, this research. But although it has been studied for many years, but none of them is on the market, right? That's very unfortunate. Okay, here is the mechanism of the this solar energy conversion to electricity. That's what I already introduced. Here, this ruthenium dye, you see this one. Actually, since people usually use this ruthenium dye, this ruthenium dye is very expensive. Okay, so DSSC, the lifetime is not very long and also very expensive. Okay, anyway, this ruthenium dye receives solar light. Okay, this one, and then excited. Okay, the star means excited state, and then excited state now what? Deliver uh, the electrons. Okay, as a result, this ruthenium divalent to become trivalent. All right, and then electrons are generated, and electrons are injected to this stellar nanoparticle, and then eventually to this FTO. Now electrons flows through the circuit from tin oxide electrode to platinum. Okay, here this cathode is platinum. Okay, as you know, this dye-sensitive solar cell uses very expensive ruthenium molecule, and also platinum. This metal is very expensive. Okay, so construction fee price is not cheap. That's one of the big problem. Okay, at the platinum electrode, as I said, this triiodide react with electrons to become reduced to iodide, and then this iodide reacts here ruthenium trivalent species, and it makes triiodide again and ruthenium divalent. Okay, so everything goes back to its original state. Okay, this way, so solar light is converted to electricity. Yeah, this looks quite noble, right? And that's why many people have studied, and they are still studying, this dye-sensitized solar cell. Okay, but recently another solar cell has been developed. The principle is the same, but they don't use dye sensitized molecules, but they use perovskite new material. Okay, that is called perovskite solar cell. Okay, but I don't introduce the solar cell. Okay, and here biosolar cell is very promising. Okay, this is on the development stage. Okay, since my expertise, yeah, I'm studying now these biosolar cells. Okay, so I have much to say about these solar cells. And but if you are interested in, and you take my another course, bioenergy chemistry. Okay, anyway, the converting sunlight or solar light, yeah, uh, to fuels, okay, not only to electricity but also to fuels such as hydrogen and methanol is very important. Okay, that's very important. Yeah. Solar light is free. you know every second a lot of solar energy impinges on the earth's surface. Okay, so people estimated that if we fully collect solar energy for 1.3 hours, that is equivalent to the total energy consumption by human for a year. Okay, now you have some feeling. Okay, so that's why the solar energy conversion is important. Solar energy and solar light is free and is absolutely clean energy. Okay, so now let's consider converting sunlight to fuels and not to electricity. This area is very active and very important to solve the human's future energy problem. The one of the alternative ideas is to utilize the sunlight. All right, but we know the photosynthesis, for a long time. Photosynthesis, this process have provided this fuel for humans. Okay, the photosynthesis everywhere. The green plants and the um, algae. Okay, algae like there are many kinds of algae, and cyanobacteria. Okay, they also do photosynthesis. This overall reaction is really simple. Okay, in the photosynthesis, carbon dioxide in air is fixed, okay, by the green plants and algae, okay, or cyanobacteria. Okay, using this photo energy, the CO2 and water uh, is used as fuels to synthesize the carbohydrate. Okay, this is a representative expression for carbohydrates, and also this process produces this oxygen as a byproduct. Yeah? So we have oxygen in air. Okay, so that oxygen is produced by mostly photosynthesis. Okay, so people have thought that, oh, this photosynthesis is a very efficient way of utilizing sunlight. Okay, mm, let's utilize the photosynthesis, okay, to produce not not this carbohydrate but hydrogen molecules or other fuels. Okay, that's very important. Why not? Okay, but the problem is not that simple. Yeah? In the research laboratories, people have succeeded in producing hydrogen. I'm also doing, producing hydrogen, using cyanobacteria, and partly I have success, but to use in a large scale, there are a lot of obstacles, yeah, to overcome. All right. Let's take a look at the current situation. Okay, in the current situation, I mean the energy situation. It is very serious. I would say, current energy problem is really serious. Okay, the left hand figure shows you the electricity production cost depending on the method. All right, the x-axis is cost, is the cents per kilowatt hour. Okay, to produce this much of electrical energy, now how much dollars cost. Okay, you see, the lower the better. Okay, well, for nuclear electricity generation is actually is a very cheap one. Okay, it cost is very small, and gas, using gas, yeah, and then you can burn this gas, and then you can operate the turbine and then electric device. Yeah, and also this is cheap. Okay, the problem of using gas or coal is that a lot of CO2 gases are produced. Okay, CO2 is a greenhouse gas. Okay, so people try to avoid to use the gas and coal. Well, what about the nuclear, power plant? You know, our government policy is to avoid nuclear power plants. It's okay, to me that's okay, but it is too premature. Okay, too early. Yeah, the government decide to shut down the nuclear power plant, but I think it's too early. Yeah? Anyway, that's my opinion. And then the wind power is very promising. Okay, and then it's the cost is very wide. Okay, here if you have a strong wind, and then it can be a very promising alternative. All right, but if you don't have wind, and then this wind power plant may cost a lot. Okay, and our country, very unfortunately, we don't have a very strong wind. Yeah? There is just a few places. But anyway, the wind power is absolutely clean. Yeah? And biomass, people have used the biomass. They cut wood, yeah? And then they simply burned. Okay? And biomass, and then the cost is uh, the range is very wide. And small hydroelectric, yeah, it can be an alternative solution. And small hydroelectric is that in Korean is a 소수력, kind of 수력 발전, but 소수력. Okay, by hydroelectric production, you mean you may think that a very large you see the power plant like Shansha Dam, it generates a lot of the hydroelectric power, but the size is huge. Okay, but if you have some small faults, okay, and then you can what there you can use the small hydroelectric power, okay, to generate small electricity. That's okay. But so far the solar voltaic cell, okay, the cost is very high at the moment, and solar summer electricity is also possible, but the price cost is much higher than the currently available these energy sources. Okay, that's why we need more research, okay, on this area. And here, okay, this the next figure shows the CO2 generation per kilowatt hour. Okay, as you see, if you use gas or coal, the CO2 generation production is a lot. Okay, hydroelectric power also you produce some amount of CO2. But wind power, I said is absolute clean, but actually wind is absolute clean energy. But operating that wind power plant, in the process you may generate a small amount of CO2, but it is tolerable. Okay, and photovoltaic cell, that's the most promising in terms of produces CO2. Okay, photovoltaic cell produces the smallest amount of CO2. So in this sense, this is the best one. Okay, but as you may think that it has a serious disadvantage, uh, which is during the night you cannot generate electricity. Okay, and if the weather is cloudy, and then also the electricity generation falls. Okay, very sharply falls. Okay, that's the problem. Hmm? But from these figures, we can conclude that it is of utmost importance to develop alternative energy sources. Okay, but here, there are very important conditions. Alternative energy sources. There are many alternative energy sources, but mm, to apply, yeah, that energy sources, they should be sustainable and carbon neutral. Okay, these two conditions are very important. Sustainable means that the those energy sources should be regenerated, or it should be obtained freely. Okay, the solar power is sustainable because it is free. Yeah, it originates from the sun. Okay, and it doesn't no, generate any CO2, and also carbon neutral condition. Yeah, this is also very important. For example, the fossil fuels like gas, coal, and oil, you know, when burned, they produce CO2. Yeah, so in air, the net CO2 concentration keeps increasing. Okay, that's not carbon neutral. Carbon neutral means the in and out carbon what amount is zero. Okay? In this sense, the biomass is satisfies the carbon neutral condition. Mm. You may think that if we cut the wood and then burn it, and then the CO2 produces into air. Why? Is it carbon neutral? But think about that. And the trees grow, okay, grow. So if your cutting rate and then growing rate is the same, so eventually the carbon neutral conditions is met. Okay. Yeah. So I strongly recommend you to pursue your future expertise in a field of energy or in environment. Okay, we the whole the humans, okay, our humans uh, meet. Currently also we meet the environmental problem and also energy problems. Okay, so. If you pursue your career in those fields, and then you can easily find your job. Okay.